Okay, my friends. So if you want to play along with Excel here, make sure you have this this Excel sheet open right next to the playlist of videos. Okay, so here are our Del Taco half-pound bean and cheese burritos. I got 30 measurements here. You're going to need three things to, average, sample, standard deviation. I'm probably going to have to go spell those right again. And sample size. Okay. Now, I'm going to blow up this column there so it fits. Now, Excel's got formulas for all these. I know we've learned them a couple times. We're going to relearn them in case we've forgotten them. Average is just that. It's average. All averages are done the same way. Average. And then we just select all the data. So on average, these puppy dogs weigh 0.526 pounds. So right away, the sample average is above half a pound. And that's good, but we know that that doesn't mean a whole lot by itself because, well, first of all, this sample is only based on 30 data points. And number two, I mean, who's to say that these are going to look the same as they are in the general population? So we need a sample standard deviation equals. And the STDEV is the one you want to use here. Oh, it looks like they've actually updated it a little bit. Yeah, this is the old one. It still works. I'm just going to use STDEV because I'm old and it's old, and that makes us both old. So we've got a plus or minus 0.025 pounds. So very, very little difference in these burritos. Okay, that means the people are making the burritos well, I guess. Sample size, there's a fun command called count. And you can just highlight a bunch of stuff and it'll tell you how many things are in that list. And there are 30. So you can get the data off your block of, you can get your statistics off that block of data pretty quickly. Okay, so now we're here. Now you want to use your Excel calculator in Canvas. So let's go check that out next. All right. We're in Canvas. Go over to your Excel calculator. It'll be another download. You might want to just stick this thing right on your desktop of your computer and just keep it there. I shouldn't update it very much anymore. I don't think anyway. Anyway, okay, it opened over here. I'm going to bring it over here so we can see it better. All right. Enable editing, faux show. Group data, this is a nice thing to have handy in case you ever have data given to you. This will also calculate the average, the standard deviation, and the sample size for you right here in case you have grouped data. We'll make sure that we see some of those because you'll probably see those in your careers. We're going to wander right past confidence intervals for proportions and sample size for proportions and go to confidence intervals for one mean, the average. All right. And all you've got to do, my dear friends, is fill out these three cells, which is X bar, sample standard deviation, and sample size. And I bet you we can even copy and paste from here. Where's that spreadsheet? Here it is. I bet you we can just copy. Be careful with this when you copy and paste in Excel because it just copied formulas. So I'm going to do a paste special, paste values. And there they are. It brings them right in. When I press enter, boom, everything updates. So let's just look at real quick at the how the spreadsheet changed when we dropped all that stuff in. Here are the values we pulled from the computations. The confidence, I got it set at 95%, just like we use typically around here. You'll notice that the critical value is a little bigger than the 1.96. That's because this thing has fatter tails. Remember, small samples, whatever small means, this thing has fatter tails to make up for that. There's also another secondary reason about standard deviation why the tails are fatter too, but don't worry about that. The big thing is that it's a little less certain with smaller samples, so we make the tails a little bit fatter to make the margin a little tiny bit wider. Very, very good. Very, very good. Okay, so over here, there's your sample average, 0.53. There's your margin of error. This is that calculation you saw on my chalkboard, the T critical value, which is this puppy dog right here, times the sample standard deviation divided by the square root of the sample size. And you can actually see the formula right there. It's being used. So here's the X bar plus or minus the MO. And then down here is the actual confidence interval itself. We can be 95% confident that the average weight of a Del Taco half-pound bean and cheese burrito is between 0.52 pounds and 0.54 pounds. Now, this tells us something, doesn't it? Notice that half a pound is not in that interval. It's below the interval, which tells me that on average, assuming a good random sample, which could be argued since all these came from the same Del Taco in the same town, assuming a good random sample, on average, Del Taco is overweighting their burritos. Probably because we live in America and everybody wants to sue everybody else for anything, no matter how simple. But it probably is kind of a consumer cover your butt kind of thing. I decided to take a look at Del Taco's nutrition facts to see if that could give me a glimpse too. And if you take a look right here, you can see that the gram serving weight for a Del Taco half-pound beef and cheese burrito, as reported by Del Taco, is 241 grams. Now, being an American, I have no idea what 241 grams is, so I go to my good buddy Google and I ask it to translate that for me into pounds, and it tells me about 0.53 pounds, which tells me that the weight they are advertising, 0.53 pounds, is actually within the confidence interval of what we actually found. So, big takeaway, they're calling them half-pound bean and cheese burritos. Yay. They're actually statistically heavier than half a pound. And they know that. They're actually, well, I shouldn't say that. It appears as though they know that and they are overfilling them kind of to cover their butts. All right. Now, this video was exceptionally short compared to the other videos today. That's because the other videos today were kind of explaining to you why these formulas work. Once you have the formulas, your confidence intervals are as simple as coming up with the sample average, sample standard deviation, and sample size, and then running it, and then interpretation, which is always the most fun part of statistics anyway. The math is pretty straightforward. It's the interpretation, like we just did. We could tell that half-pound bean and cheese burritos are actually, on average, heavier than half a pound. I think you're ready to try the homework. Go get them.